Good afternoon, everyone. Thank you for being here. My name is JD Oxford, the manager of the Industry Liaison Office for the Center for Construction and Engineering Technologies. And this is the program or school overview for the School of Mechanical Engineering Technologies. We're fortunate to be joined here today by the chair of the school, Dr. Ian McNabb, program coordinator Parneet Sagu for T173, Mechanical Engineering Technician, CNC Precision Machining, Professor Ala Rubai, program coordinator for T182, Electromechanical Engineering Technology, Power and Control, program coordinator Diana Brahaj, professor and program coordinator for T171, Electromechanical Engineering Technology, Building Automation, as well as Professor Alma Kanetsi, I believe a math professor in the School of Engineering Technologies and Architectural Studies as well. I am going to hand control of the screen over to Professor Sagu to take us through the presentation, but you'll hear from many voices, including hopefully a recent graduate of T173, Eldo Jacob Joy. Thank you, Eldo, for joining us today and sharing your experiences as we get through today. Okay, thank you, everybody.
Okay, good afternoon, everybody. I hope you guys can see my screen clearly.
You can.
Yes? All right. So today we're going to be going through the four of the programs in our School of Mechanical Engineering and Technology, starting with the CNC and Precision Machining, Mechanical Engineering Technology Design Program. We're going to be talking about Electromechanical Engineering Technician Program. We'll also talk about Electromechanical Engineering Technology, Building Automation T171, as well as the Power and Control T182. Once again, my name is Parneet Sagu. I'm the program coordinator for T173 CNC and Precision Machining, and a former graduate of this program as well. So agenda for today is COVID-19 information page, school overview programs overview, our facility, and at the end we'll have time to talk if anybody have any questions or so far. We have one of our graduate here as well, Jacob, and you guys can talk to him, chat with him as well. All the information related to COVID-19 can be found on the given link. We are partially back on campus and expecting to be more than 50% on campus in the winter semester. We all are very excited to get back to the campus now, of course. And School of Mechanical Engineering and Architectural Studies have two schools, School of Engineering Technology and School of Architectural Studies. We from T173, T121, 146, 171, and 182, and T149, we are under School of Engineering and Technology, and Dr. Ian McNabb is the chair for that school. Starting with T173, which is CNC and Precision Machining program. Before I start with this one, I want to just step back to this screen and want to tell everybody one thing is, in all our programs, T173, 121, 146, 171, and 182, we have common first semester. So after the first semester, if anybody feel that they think they more belongs to design or electromechanical or a building automation, depends upon the availability of the seats. You can switch in between the programs without losing any time, any credit. So you can start second semester, that's where the shift happens, program specific. T173 is a 2-year program packed from semester to semester, no break in between. 4 semesters on campus, 1 semester co-op that is primarily done with our industry partners. This program integrates the precision machining method with advanced computer-aided manufacturing in the state-of-art precision machining, CAD, CAM, CNC, and research labs. Our labs are state-of-the-art, our machine equipments are state-of-the-art, and to endorse that, once again, we have a graduate here, who can endorse that, who graduated recently from this program as well. Again, the student design and manufacture tool, jigs, fixtures, precision fabrication assemblies, and prototyping using computer-aided design, computer manufacturing software, precision machining equipment, and sophisticated CNC machine tool technology. In their final year, students augmented their learning by engaging in a 15-week co-op placement with our industry partners, extensive hands-on manufacturing practices that better prepare our students for the technical challenges they may face in their workplace. All our professors have a strong, very strong industrial background, and most of our professors are currently working closely with the industry or in industry as well. Even 21 is a 3-year program with one first and second semester is common. A solid grounding in engineering science and practical hands-on experience in mechanical shop and computer-assisted design laboratories provided the combination of applied and theoretical knowledge that employers expect in today's integrated world. The courses included are engineering, drawing, engineering design, conventional machining, CNC machining, CAD/CAM application, engineering mechanics, dynamics, applied mathematics, fluid mechanics, and the list goes on for those topics that you will be using in the industry. Field study in the form of applied research with our industry partner is provided to all the students. Electromechanical engineering technician program for those who have a bit or a combination of an interest in a mechanical and electrical. This electromechanical engineering program will prepare you for a rapidly changed demand of a North American industry environment. Today's companies require employees with the multidisciplinary expertise that combines electrical, mechanical, controls, engineering skills, along with the installation, maintenance, and operation of increasingly sophisticated and automated equipments. T171 and T146 have significant overlap of the courses after semester 1 as well. So students have an option to get into T171 as well. This program is specialized in a building automation and is an emerging and growing employment opportunity, especially in the construction and a property development sector. I have personally seen that how this demand has been increased. I remember to have the old style our thermostats, and now how everything is on your smartphone nowadays. You can basically control, if not more or less 80% of your house on your cell phone nowadays. And you can see the demand of this employment in this industry. Will provide you with the skills and the knowledge you need in building science, building automation system, networking, and project management. Upon graduating, you will be prepared for jobs in the industrial manufacturing sector and will have the skill set by the construction and property development sectors. Building and property managers require people to design and integrate a building controls such as lighting, telephony, security, programmable, logic controls, heating and ventilation, air conditioning, air quality, energy consumption, fire and safety. They need technologies familiar with centralized approach who can manage, control a building from an interface that provides building-wide efficiency, cost-effective operation and information. And at this point, we're not only talking about a single home. In this program, we have significant information about managing the large building like a condo building or a multiplex offices where you guys where a person who's going to be working on a job can actually manage multi-units. T182, which is electrical engineering technology, power and controls, 3-year programs gain expertise in advanced power control systems. That our program was developed in collaboration with the Toronto Hydro. And I'm sure everybody knows the Toronto Hydro very well, that Finance. It's one of our largest company in GTA. Electromechanical engineering technology power control is designed to provide students with both theoretical and practical experience, enabling them to work in a wide variety of electrical engineering area, including power and control system, utilities, industrial automation and robotics, and instrumentation and process controls. The curriculum incorporated the theory, application, practical experiences, and safety practices from power system, utilities, manufacturing, control systems, automation, and computer industries, along with the concept from the science and humanities to ensure the graduate is equipped with technical knowledge and the skills and practices. All of our programs have significant portion of practical knowledge, all programs in our mechanical school. Now we're going to talk about number of seats and the intakes. So T173, we offer 30 seats and the intake is fall and winter. T121 offers 80 seats in fall and winter, and it's a 3-year program. T146 offers 80 seats in a fall and a winter with 2-year program. 171 is 30 seats, fall, winter, and it's a 3-year program. T182 offers 30 seats in a fall, and it have 3 years in the college. Some of our courses in a first semester, that is basically is our common first semester, which includes circuit analysis, provides the information about the circuits, electrical circuits, and so on. Metrology, to better understand, we can say metrology and measurements. So in any industry, you need to know how to measure the parts. You need to know how to measure the distance. You need to understand some drawings and correlate with the measurements, and to understand blueprint reading and to create the drawing. We have an engineering drawing that clear all the fundamentals, and no matter whatever the software you use, engineering drawing is one of those courses that will help you to understand the fundamentals of creating a drawing. None of the software will create a drawing itself that is a workable drawing. All the efforts comes from the operator. Machining fundamental is a theory and visit to the shops course where we talk about how the machines work, how to operate the machines, what type of tooling need to be there for cutting the metals, different type of metals, what speed and feeds need to be there. All the fundamental knowledge will be given in this course. Occupational health and safety, of course, is one of our topmost priority as well. Safety first is our agenda as well. We want to make sure our graduates are safe on the job. Personal finance will help you to manage your personal finances, and end of the day, we all work for money, and we need to manage that, right? So we want to make sure our students are aware to make sure what comes in the account and what goes out of the account and how to pay the taxes. Basic fundamentals been taught in that. Mathematics for engineering technology 1 and college English also included in our first semester. So this is our facility. So our metrology lab equipped with the 40 workstations. Each station have their own equipments, including starting from ruler, vernier micrometers, universal bevel protractor, depth micrometers, sample parts. They are provided, and the surface plates, precision surface plates from Mitutoyo. And we got a Mitutoyo profile projectors on the far end, just below the TV. You can see the white with circular screens in there. They're profile projectors. We got a hardness testers. These equipments are industry standard equipments, full with all the packages that the industry have. precision test indicators. We have jeweled precision test indicators. They're small, can't be shown in this picture, but we have those ones. We have a set of gauge blocks as well. Number of sets. We have a number of sets for pin gauges as well. Our quality control lab, which is equipped with 2 CMM machines, robotic arm, and latest height gauge. That is, not every company may have it, but some of the industries, those are using the SPC system, statistical process control system. They do have those height gauges as well. And we also have another hardness tester in our quality control lab. Machine shops, we have over 10,000 square feet of machine shop space, and going through grinders, lathe machines, milling machines, drill presses. We have somewhere around a total of 100 machines on our floor for the students to use them. Our CNC shop, we have 2 CNC shops equipped with, starting with 3-axis milling machine. We have 2-axis lathe. We have a multi-axis lathe machine as well, which is a combination of a lathe and a milling machine. This is a cutting edge technology in the industry nowadays being used, where you can actually cut a square, triangle, or whatever the shape you want to cut on the lathe machine. We've got a 5-axis milling machine as well. We have a 4-axis milling machine as well. We have close to about 12 CNC machines altogether on our shop floor. We have a Sodic wire EDM as well. It looks little old, but again, the fundamentals remains the same with the top notch today's machine as well. And you're basically cutting with about 10 thou wire, which is pretty much a bit over the thickness of a human hair. And you're basically going to cut through the hardened steel material. These are some of our electronic labs. Every student have their own station to work on, so you don't need to wait for someone to leave the station. For pneumatic and control labs, electrical labs. All right, now coming back on to our experiential learning. So T173 have co-op after semester 4, T121 having capstone project in semester 5 and 6. T146 have capstone project in semester 3 and 4. T171 have capstone in 5 and 6 semester. T182 having a co-op in between semester 4 and 5, and then between 5 and 6. You can see that every program have some industrial experience, real world experience, which you can experience by going into the industry. All the programs are integrated with that. There are some of our projects, those are done with our industry partners, including University of Toronto robotics team as well, and a Formula One racing team. These are in the pictures from some of our industrial partners. All right, so end of the day, when we complete our programs, when we finish the college, we come to the college with an intent that, you know, after completing your program, I'm going to be working in industry, and there are all the fields that you can work in. So after graduating, T173 students can work as a CNC machinist, quality inspectors, tool and die makers, CNC programmer, junior designer, mold makers, and the list goes on. T121 can be work as industrial automation or robotics, product development engineers, research and product development, project managers, process planners, and a quality control. Even 46 can work as maintenance technician, electromechanical technician, field technician, robotic programmer, and automation. Even 73 also have a course about robotics as well, guys, where you're going to get the knowledge of robotics, same with the T146 as well, having a robotics programming course as well that we just introduced last year. T171, building maintenance, building technician, automation specialist, automation technician, automation equipment installer, and automation. Even 82 is power control system technologist or technician, energy system technician or technologist, robotics and automation technician and technologist, manufacturing and processing technologist, research and product development, and system design. Here's our contact information for each program coordinator. So if you want to take a snapshot of this one, if you need to talk to anybody about your particular questions about the particular program, feel free to email us, or you can email JD as well, and we can transfer to the appropriate department and appropriate person as well. Right. Thank you for your time, guys. And now it's your time to ask your questions.
Thank you, Parneet. I'm just putting my, as you said, everybody's welcome to contact anyone that was listed there on the screen or myself for further information and follow-up. I'm just putting my email address in the chat there for reference. I see Jeremy, Mateo are there. If you have any questions, certainly feel free to come off mute and use your microphone to ask any questions, or certainly type in the chat if there's anything that you'd like to know. As we mentioned earlier, sorry, I've been calling you Eldo, but I gather you go by Jacob. So Jacob is here with us as a grad from T173, who finished the program back in March and is now working, having completed the program, the 4 semesters in class, and then the co-op term at the end of the academic pieces. Jacob was fortunate enough to secure a longer term role with the company that you did your co-op term with. Can you explain to us what it was like making that transition from in-class work to then, getting into working for the co-op piece, and then how you, whether they approached you or whether you talked them into keeping you on longer term? What was that transition like?
Yeah, George Brown helped me a lot in finding the strong relationship between the theory and the practice, because the infrastructure, like we have almost 10 CNC machines, HAS machines, which provided me a lot of opportunity to expose myself into the cutting edge technology. So that helped me to ace the interview. For the co-op term, I had a formal interview where they asked me a lot of questions regarding machining, about tool manufacturing, about mold making, all those things. So I had the fundamental knowledge. Using the fundamental knowledge, I was able to ace those questions, and finally they gave me a co-op term. The co-op term was almost 1.5, 2 months long. And during the co-op term, I learned a lot of things, what I studied at the college. I was able to apply a lot of things, what I practically did at George Brown. And they were very, mostly into the details, because precision machining is all about manufacturing parts to the right dimension. Otherwise, the assembly will go wrong, everything will go wrong. There will be a lot of losses for the company. So after the co-op term, they found that I was a right candidate and they took me in. In the co-op term, I was primarily given with testing tasks, basic machining task, or basic CNC machining using CNC. They gave me the blueprint. I had to read the blueprint and manufacture the parts accordingly. I took assistance from senior personnel at the company, and when they absorbed me, I had to do everything by myself. They gave me a machine, they gave me the blueprint, and at the end of the day, I had to produce a part. So that was a little bit challenging at the beginning, but now I'm getting used to it.
That's great. I know it can be a more steep learning curve than you might have expected, but hopefully you felt
yeah.
very...
But at every point of the transition, you have people to help you on the project. You will have weekly meetings with the managers, so that they will explain what can be done better, what better practices can be adopted for making better products. Yeah,
that's great. And I gather, as you said, that some familiarity with the equipment that you had trained on in the labs and shops on campus helped ease that transition. I'm sure once you get out there, everything is just sort of bigger, or
yeah. The HAS machines,
the
the new HAS machines at George Brown is really a wonder, because they have such an advanced technology compared to the previous machines what is used in the industry. We have a mix of old and new machines.
Okay.
So George Brown has also a set of advanced machines.
And you're talking a little bit about the scale of the projects you're involved with, or the output of the projects you're involved with now. How does that compare to what you were working on when you were studying?
During my time at George Brown, we were engaged in making two projects. One project was a pneumatic engine, and the other was a two-stroke engine. So it involves parts, a little bit complex in nature, and we had to assemble it. And finally, we had to run the engine. That was what we did at the college. But when it came to industry, basically we were making static parts, like inserts for the molds, because the mold basically consists of assembly of a lot of inserts according to the contour of the parts. So initially, I was engaged with the manufacturing of inserts. We used different materials too. We used steel, aluminum inserts, steel inserts, as well as another QC30 parts too.
Okay. And I think you said just the size of the
the size of the molds. It was a large mold maker. We had molds of all sizes, and they serve customers according to the complexity too. Some molds are very complex in nature. That takes a lot of time, probably 6 or 7 months for one mold making machine to get completed.
Wow, I didn't really think about how the duration required, or the time needed to produce molds of that. Scale that I mentioned. Wow, and so when you were out working in the field. Did you sense that there was an opportunity to stay longer term if everything went according to plan, or did you start to sort of ask questions or see what they had in mind for you longer term? How did that process happen for you? Was it just that you were so exemplary, you were so outstanding that they couldn't possibly lose you?
No, actually, that comes because there are some areas which I had to develop. At the same time, I was good at many other areas. So they chose me a place in a company in the company in such a way that it doesn't harm them. They chose the right place for me.
Okay, where your skills could shine.
Because my skills could shine, because there are so many vacancies as mold maker, as well as for machining, for quality control. So initially I was placed in the machining, but if I wanted to transition to the design, I had to study the mold making. So after the machining, I was placed in the mold assembly for a few months, so that I get the knowledge and the expertise of how to assemble the molds, so that it gave me a better insight into the machining field.
Okay. Okay. I think that's really an important part of transitioning from the classroom to the working world, whether you're going through a co-op term or working on a capstone project or whatever it might be, is to find hopefully you find the right fit and the right opportunity to use the skills that you're developing and something that is of interest to you and that you feel is rewarding on some level, that the work that you put in the classroom is now able to shine in the working world, and that people notice that and want to put you in a position to succeed and grow in that role. So I'm glad that you found a home at your company, and thank you for joining us and for sharing your experience both in the program and then now out in the working world. Happy to have you with us. I see that Jeremy is there. Do you have any questions at all for us, Jeremy? Not sure if you have a microphone attached or if you're able to chat in, but certainly if you have any questions for everybody, happy to help to answer. Otherwise, we can certainly go back to the main room for the event and follow up there for sure. But thank you everybody for being here. I'm just going to stop the recording. Thank you, Parneet, for presenting, and for everybody else for joining, Dr. Ian, and we will follow up accordingly.
Thank you everyone for taking your time to attend.
Thank
Hope
you,
to see
guys.
you very soon.
Thanks. Maybe see you in the main room. Bye-bye.
Thank you. Thank you.